Okay, so with the statistics review, I introduced the idea of statistics. Hopefully this is a review, but yet I want you to focus on certain areas. What is our goal in statistics? It is to make predictions, right? We want to be able to alleviate uncertainty, and that's really important. If you have any advantage in being able to predict the future, you're ahead of the rest. And in terms of business and finance, you can actually profit, right? So we need to learn the tools of statistics. And what is a statistics? I explain a statistic is a number that you compute from a sample. And I talk about numbers you can compute. Even the sample size is a statistic. The other kinds of measures that we're interested in are the sample mean, the sample standard deviation, and we're interested in them because they are unbiased estimates of the true mean. If we were to have full information on a variable, then we would have a true mean, we could have a true standard deviation, and that's what we want to do. So statistics are meant to estimate parameters. So I just divide, I separate, tease apart those two concepts. Then I go through and talk about how you look at variables, data. And the main thing I want you to get out of this is, if we have a symmetric distribution, we can use the mean and standard deviation to make our predictions. If we have a shape that is roughly normal, then we can be even more specific about what we want to say. So I go through all of this to talk about different measures of center, different measures of spread, and I calculate the standard deviation. Now, statistics is about averages and relative measures. That's all statistics is. Most statistics are just an average calculation, even the standard deviation. So this is the sample mean, where I take a sample of data and I calculate a measure of what to expect out of the data. And the next data point, what should we expect? And we calculate this, we add up the numbers and divide by how many there are. That's a sample mean. But then that's not enough, because that just gives me one value, and we know there's some variation. The numbers vary for this example. I use this example here, the numbers vary. And so we also want an idea of how do they vary? So that gives us more of a picture of what we're looking at, and a range of values. So this calculation here, the standard deviation, is also an average. What is the standard deviation? The standard deviation is the square root of the variance. The variance is this thing here. The variance is an average of the square deviations from the mean. And I explain why. Okay, if you want to watch the video, I explain all of that, why, and why we divide by n-1, I explain. And then what's really important is I use my calculations of mean and standard deviation to make predictions. And I say, a person here, for this example, spends about $8.20. That's the average, give or take. I use the standard deviation to give the spread of the values. Most of the data is within one standard deviation. So that's in general. That's just in general. We can do that with mean and standard deviation when we see data that looks symmetric with like a mirror through the middle. And then I introduce the idea of ex ante data. So ex post data is historical data. Every data point here was taken and has no more significance than any other data point, okay? And that's why I can simply average them. But if data appear like this, the observations here in my sample have different significance. The most likely are 8 and 16. And then I talk about how you calculate a mean and standard deviation as the weighted mean and the weighted standard deviation, but we still can make the same interpretation if we assume symmetric distribution. So that's how we look at the data. Then I introduce the normal distribution, which you should have seen in your lifetime, and use it to talk about stock returns, because historically we see that returns in the stock market are symmetric. And so we can use that to make estimations or predictions, right? So really, what finance depends on statistics. Finance is a application of statistics. So from here, then I start talking about this data here and scatter plots and blah, blah, blah. So the most important thing is this. I had this in the videos, but I didn't have this document. That's why I said it's new. All right, so you have your calculators. With your calculators, enter this data and find me all of these statistics. Do you know how to do that? I mean, after you've done a review, how many of you can do that right now? Oh, good, Isaac can do it. Nobody else? So so I did it in the videos, right? Or you just know. So what you're going to enter, how you're going to enter, oh, I can do it on my, I'm going to do it with my iPad. All right, so if I have to use my, so you can tell the other students too, the remaining classes will be in the classroom. Not too many, but anyway. And then I can even stay in the afternoon to assist a little bit. All right, to enter this data, first, we're going to use second data. Good. So we clear the worksheet and we enter our data in pairs. Now, which one is X and which one is Y? Does anybody know? Or did you watch the videos, or do you know why one is X and one is Y? So one being, let me see. I'll go back here. Which one is X and which one is Y? Yes, Daviana, the first case, it's not because it's the first one, okay? Because I could reverse them, or maybe you'll see them reverse. You have to know that X is the market, because what we're saying is the market performance is going to influence this variable, okay? So this variable is returns to this company, BCE. Say it again? The market returns. Market returns, yeah. So market returns are on the x-axis, and the BCE are on the y-axis. So let's put those numbers in. So X will be 15%. We can enter as a decimal. We can enter as a number. So Y is its pair, and it's 30%. And we just enter all this data. 0.09, enter. 0.18, enter. 0.1, enter. 0.2, enter. 0.075, enter. 0.15, enter. 0.08, enter, and 0.16. Okay, let's make sure I got it right, because sometimes I make mistakes. Any questions about entering the data? You should be able to put more. Got it? Keep going. You know what? It doesn't matter. It doesn't matter. You just have to remember what you did. Because if you put it as a number, or you put it as a decimal and then you interpret it, just remember what you did. It shouldn't matter. Whatever you do, there has to be, either decimal and decimal, and then your results are decimals, or percent and percent, and your results are percent. You just have to remember. I'm just using decimals because that's a habit. I'm pretty sure if you want to try and do an experiment, you can do it just with numbers. Okay, so what do we do next? All right, so what are we doing? What we're doing is we're going to calculate all these statistics. So we want, oh, sorry, I have the wrong document. I want this document. 1 second. The documents are the same essentially, but just to avoid confusion, I'm going to do it exactly how I did it in the videos. Please, there. Yeah. Oh, one second, Daviana. Let me concentrate. Don't forget your question. I think this is it. Okay, the importance here is all I'm trying to do with this document is remind you of what you've already learned. You learned this in statistics. If you didn't learn it, you got to learn it now. Okay. So Daviana, question. This document? Oh, it's on the platform. I just opened it. So it's called risk and return. Oh yes, because it wasn't there. I just put it there last night because I had the other one there, the one with finance notation. Let me show you. This is the one that you have, right? Let me show. I have to turn that off. It's so many issues here with the Zoom. Stop share. Okay, so you have this one. Right. So now go back to the platform and it says here, risk and return revised new. This is going to simplify things because you see it now? Revised new. I just put it like last night or the night before, I think. Because it was supposed to be there. Somehow it was the other one. So these are the formulas that you're used to from statistics, mean, standard deviation, covariance, right? These all look familiar. All I'm going to do is lean on these and use the variable returns. And I have different looking formulas, but the same thing. All right, so get for me the mean, standard deviation, covariance, R. So get that out of your calculator. Tell me what you get. Right, so let's go back to does anybody know what you do next? You hit stat, right? Exactly. Second stat. So second stat gives me lin. What does lin mean? Linear. Because what it's trying to do is this calculator is for two variables. So the most basic relationship between two variables that we can describe is a linear one. So this is going to give you the estimates for a linear relationship. So scrolling down, you get the results. N sample size is 5. X bar, right? So that's the mean for X, the mean for the standard deviation for X, and then this. What is this? What does it mean? No. Okay, so what's the difference between this one and this one? Both of these. Very good. So what is it? How excellent. So how does it affect things? This is for the standard deviation of the sample, and this is for the standard deviation of the population. Which one is bigger and why? The data. We divide by less, right? So the sample standard deviation is a formula. Let's go back to that formula. So look at the formula for the sample standard deviation. Remember, we're dividing by one less for the sample. If we believe this was all the data, and this was not a sample, this was the population, we would have to divide by n. But because it's a sample, we divide by one less. The effect is it's a little bit bigger, so it crosses over. It does a better job of describing the data in terms of its variation or change or spread. Okay, excellent, Daviana. All right, so back to what I was doing. So let's get back to what I was doing. So this is the one we use because we have a sample. We don't believe that's all the data. It's just a sample, right? So we use this one. This one we ignore, but we understand what it is. It would be dividing by n, treating the data as though it was a population set of data. That's right. Got it. Got it. Then all the statistics for y bars, the sample mean, the standard deviation of the sample for y, and then the treating the data like it's the population. Okay, now keep going. What's this? Okay, it's A, but you can call, huh? What does it mean? Let's keep going. Let's keep scrolling. Keep scrolling. It's that. What is that? So that, and then this. No. All right, so let's remember. Okay, so this is the line, right? The line. This is the y-intercept. This is the slope, and this is r. So let's look at our data for a moment before we, okay, so we can blindly just get these numbers out and interpret from the numbers, but let's look at the data itself. Go back to the data. Let's look at the data. What is the relationship between these data, these returns? What's the relationship? How would you describe the relationship? The return of x, exactly. So return of y is exactly 2 times all the time. 2 times, 2 times, 2 times, 2 times, 2 times. So what is the correlation? If they're exactly 2 times, what's the correlation? What does correlation mean? It's the direction and the strength between a linear relationship of 2 variables that are quantitative. That is the correlation is a measure of direction and strength of a relationship between 2 quantitative variables. Exactly. So because it's exactly always 2 times, it's perfect. The R is 1. And look at what we got on our calculator. The R was? That's what the 1 means. Okay, so the 1 is the perfect relationship. It's positive. So I said direction is positive and strength is perfect. 100, well, not 100%. You say it's perfect. And then what is the 2 then? What is B? It's 2 times greater. So that shows up in the slope. Okay, so that's what the slope is. So what I've just done now is graduated you from basic statistics to finance statistics. All right, now we're using financial data, the tools from statistics, and we can do this. So let's do a step further, okay? Let's go a step further. We got the mean, we got the standard deviation for both variables. Let's get this. Can we get this out of our calculator, covariance? Because we got this from the calculator, and the calculator made this calculation. Either use this formula, or this formula, all right? However you look at it, R, the correlation, is the covariance, this thing here, divided by the 2 standard deviations. R is a standardized covariance. It's taking the covariance and standardizing it down to a range of values. R is between -1 and 1. You guys remember this, right? I'm picking from your brain. I'm triggering for memories in your brain. I think you would remember that. So this R is a standardized covariance. Oops. Sometimes these things pop up. I don't know what they are. Double tap to edit. I don't know. I don't know what that is. Why it's doing that for me. Let me go out for a minute and go back in. All right, so ignore this box. I don't know why it's there. So we take the covariance. The covariance, let's look at the formula for covariance here. How do I get this out of my calculator? Perfect. So get it for me. Do it. Well, your calculator will give you R. If you want covariance, and the reason we don't use covariance is because sets of variables, it's basically not standardized. If I take these two variables here, and I want to understand how they covary, I look for the sign, which is going to be positive. We already know this is double. But the covariance for another set of data, even though it's positively covarying, the result we get, we don't know how to interpret just that number. No, you're going to get a number here, and it's not going to be that meaningful. So that's why we standardize it, dividing by the two standard deviations to get a number between -1 and 1. So if you can get this from your calculator, let's see what we can do. So let's go get the standard deviation of X and Y, and let's save them. I noticed this the other day. Discounted payback period is in our calculator. I don't know how to use it, but payback period. Did you notice that? I don't know. I just came up because I accidentally clicked NPD. Anyway, don't worry about it. You can calculate that by hand anyway. So let's go back to my statistics. So here is the standard deviation of the X. I'm going to store it, store 1. And then I'm going to keep going and store the standard deviation of Y, store 2. So now they're both in my calculator. I have to remember where. If you want to make a note to remind yourself, you can do that. And now I want to take, well, I know R is 1, right? So I don't have to store that. But if it was a long decimal, you could store that too. So 1 times recall 1 times recall 2. And there you go. That's the covariance. Exactly. It's a very good point to make. It's just a value. It's not a percentage, and we don't interpret it as nice as we do R. It's like, so what? That's the number. But if you divide that one by recall 1 and you divide by recall 2, you should get back to 1, just to check I didn't make a mistake. So, okay, so that's a really important trick. So this is the idea, is use the power of your statistics knowledge to get you through this. And honestly, don't know why this box has happened to me before. Just go away. Yeah. No, I don't know why. You know what? They keep doing updates of this software, and I don't get any training. Okay, here, I'll try that. There. It's the garbage can. All right, so then let's talk a little bit about, so what I'm showing you is even though these formulas are inside of the black box of your calculator, you should be able to calculate these using the formula. You should be able to make a table and calculate it. I'm not going to expect you to do that, but you should be comfortable doing that in Excel. You should be comfortable doing that manually. All right, but you don't have to if you have the skill of using your calculator. For the exam? No. Yeah, no. I say you should be able to. You should be able to sit there and come up with this in Excel or make tables. Excel will just give you the answer, right? If you ask Excel to calculate the covariance of these two, it'll just give you an answer. That's different than saying make a table and calculate step by step, which we're going to do because we're going to talk about a few things in a moment. We're going to do that too. So you should be able to do all things. Use your calculator, use Excel. You should be able to make a table and solve as well. But in the end, all you have on your exam is your calculator. So that's the skill you really want to master. All right, so these are just variations of the same formula. They look crazy and long, but they're really the same thing. This looks like the variance, but instead of the squared deviation from the mean, I take a deviation from the mean of X, multiply by a deviation from the mean of Y, add them up. I'm basically averaging them. It's an average. So it's just statistics is about averages and relative measures, always relating to the center here. All right, so then what happens? So what happens next that I want to talk about? So I got B out of my calculator. What's the black box? What's inside the black box is this formula. Okay, so because it's only two variables, this is a very simple version of how it's calculated, but really linear regression comes from minimizing the residual, the squared residuals, right? So it's a minimization of being, it's the best line, so the linear regression line will be the best line that fits closest to all the points in the sense that the dots around it, or the observations around it in the scatter plot, so this is not the drawing, right? The drawing for this data would be exactly just to make it simple, it's like this. Perfect. That's what it would look like if you put this in Excel, which you should be able to do. Let's say the data looks like this. This is still going up, but it's not strong, right? The R is less, right? So the R here would be 1 in this first one. What would you say the R here was? Like it's positive, but like 0.65, 0.7, it's more spread out. The line that's fit, I can't do it. So the line that fits through here would be perfect, right? The line that fits through here has the same slope as this one, but the observations are more scattered around. Okay, so we would pick the line that comes out of the optimization problem that is really a calculus problem, but I don't use calculus here at this point. But the result of doing an optimization that minimizes this distance, it lays the line so that it fits evenly between the observations above and the observations of below. So it just falls right in there. And as a result of optimizing it so it does that, you get this really nice formula. And there's equivalent formulas for more than two variables. Okay, but this is all you need to know for this class right now. And it's R times SY over SX. What does that tell us? The slope is a different concept than the R. R is how close it is to the line. The slope is the tilt of the line, right? How one influences the other, the trend in influence. But they're related. They're different, but they're related. How are they related? I mean, what's a simple thing you can say about it? R and B have the same sign. How do I know that? In other words, if the slope is positive, the R is positive. Positive correlation. And it has to because goes up. Okay, so visually you're thinking that, but let's look at it mathematically. How do I know that B and R have the same sign? I know because these two standard deviations are positive. They have to be positive because they're the square root of a variance. They have to be positive. So because those are positive, R and B are the same sign. Only the sign of R is influencing the sign of B, not the S's. All right, so this actually in finance, it's okay. So in mathematics and statistics, we call it a slope. It's the marginal, if you say it in a more fancy terms, it's a marginal effect of X on Y. So for 1 unit change in X, it tells you how Y changes. It's a marginal effect. That's the way you would say it in economics. In finance, we interpret it a different way. Not a different way, but a more sophisticated way, because we're using returns. And particularly, I'm going to use market returns, and I'm going to use different firms at a time, and I'm looking at the relationship between them. That's what I'm going to do with this relationship. I'm not just taking random variables. I'm taking the market returns. It's a very specific thing I'm doing here. And this is some firm. Let's say these were the data, for investing. So it's considering investing or purchasing the stock of BCE. How do you feel about it? You think it's a good thing? You get double, right? It's great. But what if the market experienced a recession or a depression and the returns are negative? Then it's double negative. So it's very sensitive. Okay, it looks good in the positive, but what about the downside, which you need to consider? Okay, so this is a measure of sensitivity. So you can think about it, for 1 unit change in X. So it's a sensitivity of the firm returns to the market returns. And we give it a special name. Do you know the name? The other one. Beta. So that's beta. So it's just a slope. It's just a slope from statistics. But in finance, using these variables, market returns and firm returns, you interpret it as a beta. So which beta is more useful? The beta from this with the perfect correlation, or the beta from this one? The first one, right? The beta from this one is more certain because the line is perfect. I'm more safe within this range of data if the market is performing between 8% returns and 15% returns. I feel good about investing in there, right? But when there's volatility, there's some spread, I'm not as 100% confident about. Right, this never happens, but it never happens, but it helps you remember the difference between R and B. That's why I use the example. The closer to 1, the better. You should be able to graph, but I probably won't ask you to graph it. Well, no, there's going to be graphs. There's going to be some types of graphs, yeah. Not this graph, but other graphs. All right. So, okay, everybody gets this. So this is bringing statistic tools into finance. And in particular, we're looking at the relationship between market and firm returns. And so that is for data that are called historical data. Every observation in the sample provides the same quality of information or the same degree of or impact of information. I don't take any one value more seriously than any other. Okay. So is there anything else I have to tell you? So we're going to talk more about the beta anyway. That's what we're going to talk about. So what if the data look Yes, it's a sensitivity of firm returns to the market return. Now, usually in statistics, when you learn about correlation, you're supposed to not consider correlation as causation. However, so just because we see these related doesn't mean one causes the other, right? But over time, over decades of looking at financial data, we're comfortable to think that a firm is affected by the market, right? So we do write them like this, saying, well, the market performance impacts the returns for a firm. All right, so what if the data appear like this? What do we do here? So in this case, I have simplified the world into three possibilities. And this was done looking at historical prices, looking at using fundamental analysis and financial statements and predictive models. So let's say I used everything at my disposal to come up with three possible states of the world. I summarized it as three. Now, in reality, how many possible states of the world are there? It's infinite, right? Who knows what's going to happen tomorrow? Who knows? But I've simplified it. I'm confident I have three states of the world. So this simplifies the mathematics, but in fact, you could use a distribution. This is actually called a discrete distribution. That's what this is. And it's all I'm going to stick to. But when you go on in statistics, in finance, you could use a continuous distribution, not a discrete distribution, to do this. But I'm making this as simple as possible. So it's just three possible states. Here are the returns to the S&P 500 and the firm. And now I have different looking statistics, but the same idea: the mean, standard deviation, covariance, correlation, three different formulas, and the slope. But I use Greek letters. Why am I using Greek letters? Do I like to look fancy and use Greek letters? What is it conveying that I'm using Greek letters? Okay, so why didn't I just call them? Why didn't I just use the things above? Why didn't I use X bar, S, covariance, R? Why did I use Greek letters? I use Greek letters because the Greek letters are reserved for parameters, right, from the population. So I'm treating this like it's a population information. I'm saying the only possibilities are boom, normal recession, and these outcomes. That's what I've done here. So because of that, that's why I use the Greek letters. So now you see the beta, right? You feel a little more comfortable. They call it beta because it's the Greek letters using, so you might, equal, we're looking at both, but we're using the market, we're using the relationship we're not looking at two returns together. In particular, to do what I'm doing here, I'm using the market and at some firm, okay? But we're gonna talk about two firms and two stocks as well. Yes, and you know what? Ex ante, the point of this set of formulas and this illustration that I repeat many times is to introduce these different formulas to you. Okay, that's one thing. The other thing is the idea of using these symbols. In fact, unfortunately, in finance, they just use these, even if they have a sample later. So don't be discouraged that you know the difference between a sample and a population, but there's a tendency just to use these symbols all the time anyways, regardless. But in particular, the idea is it's supposed to represent that it represents all the possibilities, or the population data. So did I answer all the questions? We are going to do the same sort of calculations using variations on the formula, but yes, it's distinct in the sense that there's only 3 possibilities here, and we're going to use it to come up with estimates. Yeah, you'll find out when you do this, if you go through. So let me say one thing here. How can you put this in your calculator? Do you know if you can put this into your calculator? So the first one we learned how to do. Do we have these programmed in our calculator? You don't think so? You're not sure? Okay, so I'll tell you right now, in the videos, I tell you can't put these in your calculator, but we can actually get this one out of our calculator. Okay? So you can get the mean for X and the mean for Y out of the calculator, and they can help you get make the remaining calculations, which we're going to do. So let's look at let's put this data in our calculator. Let's see what we get. So if you have the HP 10B2, the HP 10B2 actually can calculate weighted statistics. Okay, but because it's not an official calculator for the CFA exam, I didn't use the HP 10B2. Probably the HP 12C does it. I just don't know how to use that calculator, so I don't teach it in the class. But I mean, I could learn it. But anyway, whatever we do in this class, you should be able to do in your calculator, and this just makes it easier. So I'll show you how to do this. I'm just going to let's get the sample means out of our calculator. So back to the calculator, getting into data, clear the worksheet first, right? Because there was something there. And so let's enter the data. The way we're going to do this is for X and Y separately. So I'm going to put into X, I'm going to put the weights. So I'm going to put 40% into the weight for 14%. And then I'm going to put 50% into the weight for 8. So you got to be careful, keeping clear in your mind what's a weight and what's your variable. Our units are percentages, but the weights are in decimals. I do that just to try and separate and avoid confusion, but essentially our value, our variable of interest, are returns, and returns are in percentages, but that's different than the weight, right? The weights should add to 1. Mm-hmm. Okay, so what I'm saying is, let me go back here. So to get this, this is called the weighted average. I want to get the weighted average of X and the weighted average of Y, and I have to use this column. So I'm going to do them separately. So you got to put these together. Yeah, well, I'm just gonna do it like this. The weight and the score, the weight and the score. So I'm gonna just do X first. So with X first, this will be my X and this will be my Y. Then I'm going to do it with y. This will be my x, and this will be my y. You have to put them together. But however you do it doesn't matter. If you're going to do x first or this, no, it doesn't matter if I put x as x and that as y. Either way, it's confusing. You just got to know what you're doing. Exactly. Use the probability as one of your anchors. So that will be your weight. So let's go back. So anyway, try it yourself, and then I'll rejoin you. So try for x first, and tell me what the weighted average is for x. See if you can. You can put it all. Just have to remember, if you put it all as decimals, your result is a decimal. If you put it as a probability is a decimal, and the other one is a number, then your results are percentages. You have to remember. I wonder how the Zoom people are doing. I'm trying to broadcast this way. I don't know if they hear me. They're very quiet. Zoom people. No chat comments. We have Yadiel and Emmanuel there. Are you hearing me okay in Zoom? So what you're looking for right now is the weighted mean and the weighted standard deviation. So how do you think you can find the weighted mean of x? Do you think this is it? No. It's not there. This is not it. The weighted mean of x, so none of this stuff makes any sense. The value that you're looking for is this one. So just keep scrolling. Keep scrolling with the arrow, or go backwards. If you go backwards, you get it right away. So these were my results. If you go backwards. 0.1. Yeah, okay, then you have to do second stat. There they are. And then grow up. It's right there. No, keep going. Just go up. So wait, look at your screen right now. Okay, so on the screen, you hit second stat. Now just scroll up. Okay, you entered something wrong, but that's it there. XY. It's where it needs to multiply. This is the weighted mean. So what you have just found is the weighted mean. So mu x, yes, 0.1. Now do the y. So second data, second clear work. Okay, so then the weighted mean for y. Make sure you make notes. You're going to forget what we did because there's too many things happening at the same time. think that's what I get. Is that correct? I don't know if that's correct, but let me check what I did. So it's the weight is 0.4 and 30%, 0.5 and 18%, 0.1. So I overwrite what I did before and I do it again. And I get 22. So that's the weighted mean of Y. You got the same? 22%. And maybe there's a way to get variance too, but I haven't finalized how to do it yet, but I got that. Pardon? I have no idea. What calculator is it? Maybe you can look in the instructions or look online. If the TI-84 does a weighted mean and weighted standard deviation and weighted covariance. Once you have these three, you can get the correlation, right? Because covariance standardized will give you the correlation, and then it'll be easy to get beta. So if you find a way to get the variance and the covariance, then this is all easy. Otherwise, you have to use the table method. But at least we have the mean, that's the weighted mean. Makes it a little bit easier. So you have lots of practice in there to do. Yeah, we're gonna get there. Yeah, hopefully. We can stay, you know, if you guys want to stay till 12:31, I'm here. Oh yeah, I just erased or something, I think, because it was 0.22. I probably hit something and it undid. Uh-oh. Did anybody else get 21? Check your numbers. Check your values. So yeah, if you guys want to try and see if you can get more weighted statistics, but I'm pretty sure the HP12C can do it. That calculator is going to take me time to learn. Anyways, I'm never going to give you more than 3 values on a test. And in the notes, I have 2 or 3 values, 3 observations. So it's quite simple. For the art, the only thing you can get out of this are these, the way that we did it. No, you have to get all of them. So in terms of practice, hold on, let me get off of here. Let's see what we have to practice. So what I did was I have the solutions for both of them here. It's got to practice. Like, so in the test, I don't expect you to write all of this, you know, but you should be able to get for this data, you know how to get it out of your calculator. We're good, right? If I ask you for the mean, the standard deviation, you can do it. You know how, right? For the ex post data, after the fact data. And then the covariance, you know how to get. But if you have to do it manually, I recommend doing it like Excel would do it. Make 2 columns, step by step. It looks like it's going to take forever. So you'd have to practice. I would never give you on a test like 5 values. It'd just be 2 or 3. 2 or 3 observations. No, now I'm going to do the weighted one. So this is the one without weights. So this one you can do, right? So let's look at the example with the weights. It's this one, ex ante. So ex ante means antes, right? Before we see the observations, this is what we predict with this model that we created, this distribution. So with this, we get the sample mean from our calculator as, the weighted mean from our calculator for X, the weighted mean from our calculator for Y. And then you can calculate the variance in columns. Yeah, you don't have to write all this. Only when you're calculating, put your steps, right? So for this one, you would put the steps. So manually, you have to do it, yeah. Unless you figure out how to use your calculator, you do it manually. So let me show you the fastest way to do this manually, okay? The fastest way to do this manually. So I've got the easily I get the weighted mean for X. So now let's do the variance for X. The variance for X, or let me use the symbols. I got to practice using the symbols. Oh, sorry. I have to go back to, thank you. Back to, all right. So, yeah. So what I'm going to do is I know that the formula for variance looks like this. So I'm going to just put it like Excel would do it. I'm going to take the column. All I'm going to do is copy. Watch me do this. I'm copying the column for weights down 0.4, 0.5, just copying it. Then make brackets, copy out that's not right, the weighted mean, and then copy the column for X. It's very easy if you think of Excel and you don't screw up. I'll get rid of that chat. So you see what I did? It looks very messy. You do understand? So then you can just put this in your calculator using store keys. You can put, this one is 0.04. This one is going to be a negative, right? Negative 0.02. And this one's going to be a negative as well. Why do I got negatives? Oh, and I have to square. That's why. Okay, try and do it like that yourselves, just to practice. Just think about the columns like Excel would. Write it down. So don't copy, just do it yourself with, I just took this column and I wrote it. I took this column and I wrote it, and then I just repeated 10% down and see if you can get the result, which I'll show you the result. And this is the variance. I'm going to get the variance first and then take the square root. So variance is sigma x squared. Standard deviation is just sigma x. So yeah, this test is about the statistics. We got to be masters so then we can easily get through our finance. Did somebody come in late to get their test? You want to get your test? You want your test? No? ¿Tu nombre? ¿Cómo es? Did you get a number yet, Melendez? No, you can keep it. You can keep it. What do you get? What do you get? You should get 0.034641 as a standard deviation, or 0.0012 as the variance. And do the same for Y. Point 0.0012. Okay, so that's going to be the variance. Both numbers are useful. Keep it as a variance or a standard deviation. Right? Is that what you got? 0.0. Oh, no, that's not good. Okay, so let me do it. Let me do it for you. So let me do it for you. So showing you how I will enter this. All right, so to put this in my calculator, I will simplify those values. Well, let's simplify them first. So the first one is 0.04, and I have to square it. And then this one is 0.02, and I have to square it. And this one is 0.06. If it's negative, it's okay that you square it then. You have to square it, right? So the negative disappears. But yeah, it's negative. I didn't put it down just because we're squaring it. So on the calculator, I'm going to take 0.04 square times 0.4 equals store 1. 0.02 squared times 0.5 equals store 2. And 0.06 square times 0.1 equals store 3. And then add them all together. Recall 1 plus recall 2 plus recall 3, and hope I got it right. That's how I would do it. Oh, you're writing it nice. Don't have to put the negative because once you square, it's gone anyways. But yeah. Oh, because you don't have all your decimals, so you have to do second. Remember this format. 9, enter. So now you will see it. Do it now. You need all your decimals. You have to format the decimals to show 9 decimal places. Yeah. Okay. Very good. You got it. Sorry, I wasn't listening. I was half listening when you were saying numbers. I'm sorry. No, you're right. You're right. You got it.
Weighted mean?
Yes.
Okay, so we have the weighted mean. And in the data, for example, this is P and Y, the data that I can put at it.
But to get it, we're going back. It's here. Oh, you don't have it.
Yeah, but I can go down.
Oh, you keep going this way.
Yeah, I have it. It's 0.10 and 0.22. But my question was, for example,
sorry. There should be a lock. Do you have a lock on the thing? Yes.
I saw, for example, SY, and wouldn't that be standard deviation?
No.
So there isn't any way that we could take a number and then divide it by
Not that I know. I mean, I'm using a trick to get the multiplication of them, but not that I know. If you put the deviations from the mean in, you could also do the multiplication, like that's this thing here, the multiple. Sorry, I'm going all the way. You can use it to get all the other values, but what you put in will have to be the deviations from the mean for the variance and covariance. You can figure out a trick to do it, but all I've got from doing that is I'm using the trick that I'm multiplying the weight with the score, the value.
So it's better just to do it manually.
Well, this will help you get just quickly the weighted mean and then to do it manually. Yeah, because I'm not going to give you, like I said, more than 2 or 3 data points. What? Yes, I'll redo it. I'm going to redo this so we can see that we get the same answer. All right, so back to my, so this is what I did. I made this calculation in the calculator using the weighted mean for X and Y, and then I just made I took the columns, I just repeated the weights, I wrote the X, and I wrote just in columns. I don't forget the square. So to put this in my calculator, step by step, I'm going to clear what I've done. I'm going to go into here. No, sorry. I want to go into, I don't have to go anywhere because I'm just going to I'm going to take my, I'm going to take my, my brackets. Let me see if I can show it. Oh, I'm going to do it like this. That's what I can do. There. It's not the greatest, but it's really small. Let me see if I, hold on. I'll make it bigger. All right, there. There we go. So what I'm going to do is first this one. So I simplified this and I said 0.04 square times 0.4 equals, and I put it in store 1. Then the next one is 0.02 square times 0.5 equals store 2. And the next one is 0.06 square times 0.1 equals store 3. And then I add them together, recall 1 plus recall 2 plus recall 3. I get my answer. Got it? And if anybody comes up with a faster way or checks the internet or can figure out how to do this faster, let me know. But this, like I said, I'm only going to give you 2 or 3 observations, so it's not going to be that hard, not that tedious. Then you do it for Y. Let's do this for Y. So I'm just going to recopy column P. I'm going to make brackets with squares on it so I don't forget. Then recopy the weighted mean in a column. And then recopy Y in a column. So I'm acting like Excel using columns. This thing came back. Oh, I don't know. I don't know where it comes from. So simplifying a bit. Simplifying. 30 minus 22 is 0.08. 18 minus 22 is negative 0.04. Just square it. And then this one is negative 12. And do the same thing. Once you have that, the only other thing you have to get is the covariance, correct? Because once you have the covariance, you have all the other values, because you can get correlation and then you can get the slope. So the top three, you need to be able to get on your calculator. Oh, something's wrong. But let me see what I got. I got, what? Oh, it's because it's on my calculator. Here, let me go through my here. My head. It's over here. Okay, so recall 1, that's my first one. Recall 2 is this one. And then the third one is this one. Yeah, so double check that one. By y? So the third one is 0.04 minus 0.1 is negative 0.06. So it's 0.06 squared, which is 0.00036. And then when you add them, so again, so this is the first, this is the second, this is the third, 0.00036. You got it, you think? So this last one, did you guys finish? Did everybody finish? So I'm going to, oh, no. I'll make it bigger like last time. And then add the, okay, so 0.08 square, store 1, 0.04 square, store 2, 0.12 square, store 3. Recall 1 plus recall 2 plus recall 3 equals? No? You didn't do it? Okay, recall 1. So 0.08 square. Oh, I forgot to multiply. That's why, guys. Let's do this again. 0.08 square times 0.4 equals, store 1. 0.04 square times 0.5 equals, store 2. 0.12 squared times 0.1 equals, store 3. Recall 1 plus recall 2 plus recall 3 equals there. I screwed up. I forgot the weight. These are my answers. 0.00256, 0.0008, and 0.0014, and then you add them and you get and that's the variance. So then the standard deviation is the square root of that. All right, and then the covariance is the only other thing you need to do. So you need to repeat with the covariance. And any questions about that? All these results are on the platform here. Okay, so I'm just showing you what I did to make the columns, even though my columns are not even for whatever reason. These are columns. And then I did it for covariance over here. I got the covariance. Now you don't take the square root of the covariance because covariance might be a negative and you can't take the square root of a negative. So we just leave it. And we don't interpret it as a percentage. All you do is you interpret it as a number, because to get back to percentages, I explain in my standard deviation video, you need to take a square root. And because you cannot take the square root of the covariance because it might be negative, we don't do it and we just leave it as a number. It's another reason we don't like covariance. We want to get rid of covariance and talk about correlation, okay? So there's my correlation. So what do we see? We see that correlation is 1. You can't really see in the data because the data is not, it's like looking at this data here is not familiar to you, right? You're not used to looking at weighted observations or weighted data. But in fact, the correlation is perfect. What about the slope? So how do we get the slope from here? The slope is equal to R times SY over SX. So I'm using these Greek symbols, but my head always thinks about the original statistics that I learned, that in original statistics that I learned, R is equal to covariance over SX divided by SY. And the B is always R times SY over SX, which is spells this mnemonic that I use, risk, so you remember. I mean, you're going to get to use the formulas, you bring the formulas to the test, but it's good to be really confident and have a check of what you're doing. You always divide SY by SX to get it, and it spells risk because beta is a measure of sensitivity or risk. Okay. The risk associated with adding, in this case, adding this firm to a portfolio of returns. Another measure of risk is the standard deviation of those returns. It depends what we're trying to talk about. But the B, the sensitivity of the firm's returns to market performance, is what this B represents. Anyway, so let's go back here and look at the results. So they're all here. This is all here for you guys to review. It's been here for weeks. So to find the slope, it's R, which is correlation, the Greek letter R for R, rho, SY, which is sigma Y, divided by SX, which is sigma X, and you get 2. So you get the same results, but it's not as easy to see with ex-ante data. The slope is 2, and the correlation is 1. So practice those, all right? I'm not going to do this anymore. The main thing was to show you that you can do this manually. Notice here I also use columns. I put the weights, and I do the deviation from the weighted mean and the deviation from the weighted mean for each variable. And sum. So practice, practice. All right. So that's what these are. These were for you to practice that. Then in this document, unless you have questions, any questions for me? Just practice those, okay? After class or tomorrow. This document So I just show that you have the results. You just got to practice on those sheets that you get the same answers. So what I've done here is just written the same formulas, but using R for return, because we're going to focus on return data. But it's the same. These are the same formulas. They look crazy, but they're the same, essentially the same. All right. What you have to remember is M is for the market returns that often I put in the first column, and it's the X. And then I is for the firm returns I put in the second column, which is Y. And even though I put X first and Y second in the columns, in statistics, we often do things in alphabetical order. So it's going to be IM, but don't let that confuse you. So we just, like in statistics, we put symbols in alphabetical order. So I put the I first and the M second, but these are really the same formulas. Why I have this chapeau, the little hat on everything? Does anybody know why I put the hat on all these formulas? This one has a bar, this one has a hat, hat. Because it's sample, because it's a sample. This is sample data. These are estimates. So I use the hat. Don't let it intimidate you. You don't have to use these symbols either. I mean, you just have to be able to read it if I give it to you in symbols, okay? And then here, oh, sorry, the people, hold on. I gotta share my screen with these guys. Yeah, sharing screen. And this data, which is the ex ante data, is all the Greek letters. No, the other way. So with the hats, it's for a sample, it's ex post or historical. When it's Greek letters, it's ex ante. Exactly. It's weighted, but more importantly, it represents a distribution of the population of possible outcomes. That's particularly what it is. Not just that it's weighted, but it's a distribution of the possible outcomes. That's the main thing. It represents the population. That's why I don't have any hats, because my estimates are all parametric. They're all parameters. They're all the real thing. I act like they're the real thing, even though. So in the end, all my letters are going to be Greek, assuming that whatever I have is good enough to represent the population. But don't be intimidated by all this stuff. It's just a deviation from the mean. This is just a deviation from the mean. The most important document in my sentiment is this one with the formulas that you know. I don't like to teach like there's 1,000 formulas. They're all the same formulas you've already learned. These simple formulas. Don't look so simple, but you'll get more comfortable with them. But these simple formulas are just adapted for finance here, okay? But don't get intimidated. It's nothing new. It's mean, standard deviation, covariance, correlation, and slope. The one thing I do here is I introduce a different formula for the slope. Actually, let's do it up here first. All I've done here on this finance thing is show you this. It's just a different version of this formula. This is so ugly with all the hats. So let's just go to this one. It's the same thing. It's just one was for the sample data, and this is for the population distribution data. But it's the same symbol. So how do I go from here to here? I'll give you 5 minutes to do the math. It's just an extra formula because we think about the covariance. So beta is also measured by covariance, standardized by the variance of the market returns. Mm-hmm.
Okay, so the bottom part of the market is squared because different the market
and the beta here is just like the slope formula R SY over SX. So yeah, so how did I get rid of the SX? How do I go from here to here? There's another formula. If you put this formula in here and do some algebra, you'll get this one. Try it. Try it. I put this in here. Do it, do it, do it. 5 minutes. I'll do it for you too, but you try. Because what's going to happen is this one, no, what's going to happen? If I put this here, this one here, the standard deviation of y will cancel with the standard deviation of y here. And then there'll be 2 m's on the bottom. So you see it? You with me? So just get used to this. This is supposed to be simplifying. It's not supposed to confuse you. When you see things, make it simple. Go back to that initial document. So are we going to stay another half hour? You guys have to go. Keep going? All right. So, okay, let me show you how I'll do it step by step. I will do it step by step for you. All right, let's do it step by step. Okay, so my question was, how do I get this formula from this one? And the key is substituting in the correlation. So I'm going to, oh, this looks a little different than I simplified this document. So I'm going to use this one. Actually, you know what? Let me get the one that I gave you. Let me save this. Hold on. So if you already got the documents, get them again because I cleaned them up a bit. I simplified them. All right, so let's do this. So I said I'm going to substitute this with this. So beta I equals, so this is the correlation between the firm and the market returns divided by the firm's standard deviation and the, oh, it's not projecting? Weird. Try that again. There. Don't ask me why. It's connected now. Okay, so I'll go back. So the point was I'm going to substitute this in here. So I'm going to do sigma I. So this is the correlation divided by the 2 standard deviations. And I'm just going to repeat what's here. So I replace this with this and put this here. Now I can do my canceling. What cancels? This is the same as this. That leaves the covariance divided by these 2 multiplied together, which is the variance. You see it? There's 2. That's 2. That's So this was the standard deviation of each. So just to recap, I mean, that's the only step. I take this, which is the standardized covariance. So it's covariance divided by Sx, Sy, Sx. That's here. And then I just repeat this and these cancel. This one and this one here cancel. And it leaves the covariance divided by the variance of the market returns. Is that okay? Do I have to do another step? If there's two? So why am I showing you that? Because sometimes the data that you have will be with correlation. If it's not, you might have the covariance. This is easier to do. These are only two things you need to calculate. And here you have three things you have to calculate. So it's reducing your work. It's also for interpretation because here it's all relative per unit change in the variance. So the impact on the covariance of a unit change of the variance of the market returns. Anyway, so what's next? Any questions about that? So that's it. One more formula. That's all I added. And it was achieved to simplify your calculations into just two things rather than three. Let's see what else. So that's all the statistics stuff. Well, you do need to watch the statistics videos. I mean, I don't know. You have to know how to interpret a normal distribution. So let's see. Let's talk about the first set of lecture notes then. Let's see how far I can get in a half an hour. So I'm going to come back to my desktop. So this is so in unit 4, we use the UR case. I'm going to come back to the UR case to calculate. Our goal is to calculate the best estimate we can for the required rate of return for UAir. UAir used 10% as a required rate of return. Remember, I don't know if you remember, but that's what the UAir firm did. But was that good? So I'm going to collect all the information I can to try and come up with the required rate of return. So in this course so far, we talked about how we value securities. We talked about how we value projects. We talked about how we value assets in general, right? Then I gave you information on so that you could create the cash flows to analyze investment alternatives, right? So unit 4 was all about, here's this information, estimate the cash flows. So we know how to estimate cash flows. We know different models for estimating for different security stocks and bonds, right? We learned all that stuff. Now we're going to go the ultimate. How the heck do you come up with a required rate of return for valuing cash flows, for getting the present value of future cash flows? Where does the R come from? Where does that required rate of return come from? That's what we're focused on. So we're focused on returns. I'm teaching you now the statistics for returns, but we're going to go deeper. The first set of notes is to talk about how to calculate returns themselves, and then how to use that to get the required rate of return. So unit 5 is focused on return. Okay. So this is the information I actually gathered. Some of it is historical. I mean, it's historical information so that we can eventually calculate the required rate of return for UAir. And I make different assumptions and things in this case so that we can do that. So that's what we're going to solve this for unit 5. This is our objective. And that was over here, called UR case part 2. All right, so now I want to go here. These are the lecture notes, and here are some review problems, and it's going to use everything about statistics that you've learned, all right? The capital asset pricing model is one, so see, CAPM. Has anybody learned CAPM before? You should have learned it in 3106. You didn't? Okay, so you're going to learn it now. Okay, so the capital asset pricing model, you're pricing assets, capital asset pricing model, and what you're doing actually to get the price, you need the return, right? All of the formulas we did to value assets had a R in it, or an I, an interest rate, a required rate of return, a yield to maturity, something. So we are going to use this model, and it's just one model. There's other models to estimate, and I'm going to talk about a couple of others, to estimate the required rate of return. That's all this is. All right, so this first set of notes looks like this. Has anybody started looking at these? You skipped? You watch the videos, or you watch the? I talked about it a little bit, yeah. Okay. Okay, so let's look at this. So what we're trying to do here is basically calculate these. This is on our return for the stock market. This is our return to a security of this firm. So I just threw those on there, but that's what that is. That represents over period one, investors in BCE for every dollar invested got 30% return. Okay. In the second period, they got 18% return. And this is a measure of returns for 500 top performing stock over this period. Okay, we're going to talk about this because this is easier to talk about, but you can understand from what I tell you about this, how this could be estimated. All right, so that's what this whole unit is about, or this topic. So what is a return? So how could you calculate a return to stock, which is our focus because it's the easiest? Dividend paying stock. Well, if you own the stock over a period, you'll get a dividend, possibly. It might be zero, but you could get a dividend. And then you could realize a change in market value. The value of the stock from the perception of investors could go up or could go down. So I use this notation here to convey that. So at time t, T could be anything. It could be today, it could be tomorrow. It's T, wherever on the timeline, all right? The point is to calculate the dollar return. I take the dollar dividend at that moment from whenever the change was, and I add it to the change in price from that what it is now from what it was before. So when you see T and T minus one in the video that I made, or I'm trying to remember, I guess, yeah, I talked about this. Basically, it could be 1 week, it could be 1 hour, it could be 1 year. Okay, it doesn't matter. It's T and T minus one. So that's dollar return, but what we work in is percentages, right? So how do we get the percentage? We're going to take this number and we're going to divide by the original price. What is the original price? PT minus one. So that's what is here in the formula. So this is the dollar return divided by PT minus one. Is everybody okay so far? So I just take the dollar return but divided by this. Now, I can write it like this. I can write it like this. If I write it like this, what I'm saying is, like, you know, when you think about when we do, when we calculate the returns, the interest and interest rate conversions, we always minus one, right? Minus one. Why? Because we're doing the returns per dollar invested. When we take off the one, we just look at the percentage. Forget about the dollar. That's what this is. This is looking at the percentage return. We take off that for every dollar invested. So this is a way we can look at that. Another way to look at it is just divide this portion by the old price and this portion by the old price. And it divides into what we call, this is the dividend yield. And this is just terminology, vocabulary. And this is the capital gains yield. capital gains sounds familiar to you, right? So what did we make on holding this as? Because actually, if you make enough, you have to report this and you pay taxes on capital gains on your investment. So we need this number. This is an important number. And we also pay taxes on dividends, and it can have a different tax rate. Okay, so these can have different tax rates. So they have specific, so these are all the same formula for different purposes, for seeing different things. Is everybody good so far? Looks familiar? All right. So always try and think, did I see this before? This looks familiar or not? So I'm going to do that to you again. Let's look at this data, or these, not the data, these formula, and see if it looks familiar to us. Oh, I have a chat comment. Let's see what we have here. He says goodbye. Bye, Emmanuel. Sorry. You're going to see in a second. Yeah. There. So in economics, whether you learned it or not, you should have learned the concept of percentage change. This is a percentage change. The new value minus the old value divided by the old value. So this is percentage change in price. But you can also do it for rates of growth rates. You can do it for interest rates. Okay, so this is a measure that you should be familiar with, and I will refer to it often. It helps me understand what I'm comparing things to. So it's new minus old over old. All right, so this is our general formula that you're going to have lots of practice with in the review problem. So what do you need? You need prices. Mostly you need prices, right? You need past prices. You need for any time. And if you think back to this, how many time periods was I looking at here? Like 5, right? So I need a lot of price data if I want to make this table. I need the price before, like the price before period 1. I need 1, 2, 3. I need all this information. So think about that. But I've just written the formula for each one at a time. So T. All right. So this is for every single period. Period 1, 2, 3. Blah, blah, blah. I also need the dividends. So those are the 2 sets of information I need. I need historical dividends. I need historical prices. So this kind of equation will be with historical data. Okay, I haven't taught you how to do this with ex-ante data, just to be clear, okay? You've seen this before. What's this? So not annuity, but perpetuity, right? So this is the price of a growing perpetuity, right? If you assume constant dividend and constant growth rate over every period T, then, so we'll replace dividend with constant dividend, C1. We have a constant growth, so there's no percentage change. I mean, it's the constant, it's always the same. So this whole thing just becomes G. And the original price is PV0. If I have a constant dividend, a constant growth, then I have a constant interest rate or constant return. So with these assumptions, that's where this formula comes from. So this one that we worked with is a more specific, with certain assumptions, version of this. So this is the more general formula for returns, okay? All right, so let's use this with some values. So the next step. Okay, just writing, let you guys write down. So this is more specific with assumptions. This is more general, the most general you can get for stock return. Okay, so let's calculate historic returns. And remember, historic returns, stock returns, those are like the assumptions built into what I'm doing here. All right, so for this information, suppose a stock had an initial price of 42. So I'm going to call that PT minus 1, right? Because it's initial, first one. Per share, paid a dividend of 84 cents. So this is DT during the year, and had an ending price of 46. So this is PT. So with that information, I'll carry the model over. All right, calculate the total percentage return. And then separate it into dividend yield and capital gains yield. How are you doing? Got it? So TT is 0.84 divided by 42, and this one is 46.2 minus 42 divided by 42. So when you do this calculation, you get the whole thing, right? So 12% return for every dollar invested. And what is the dividend yield? It's 2%. And this is 10%. Okay? So you have, in the review exercises, you can practice this. I give you some data you can practice this with. Okay, sorry. I'm using a, okay, this is good? You got it? So you're gonna practice that. And then, all right, so here's some data. 4 years. These are market returns to the S&P 500, putting together stock returns for those top 500 companies into an index relative to their representation, their market cap, right? These are all provided in a composite return. This is like the overall return over that period, 2007. Now, why did I pick 2007 to 2010? Because these were the years, this was the setting of the global market financial crisis, right? And what did you see? So these are actual data I got from the S&P site. Well, Wikipedia referencing the S&P site. So 2007, the returns were 5.49%, very low. You'll see in general, it's about 11.5% historically for the S&P 500 or any kind of broad market index. In 2008, minus 37, so people lost money, right? 2009, look at that. It recovered, but did it completely recover? And then, pardon? Everything's percent. Yeah, the percent from here goes here. So we might be interested in, over that whole period, if people were invested, for every dollar invested, did they survive? Did they make anything, or did they break even? That's what you want to find out. So you'll do that with what's called a holding period return. Then you might also want to know, on average, every year, how did the market perform? So you can get what's called a geometric average return. And then there's a regular arithmetic average return. I want you to calculate each of these. Okay, so where's the formula for this? The formula for this is here. Okay, so these are the formulas here. The holding period return, so this should look familiar. This feels like compounding, right? This is what it looks like. It's just like compounding. But the interest rate is different every period, or the rate, the return is different. But it's like a compounding minus the 1, taking off, because we want the return per dollar invested. So we take off the 1. The geometric average return is taking the holding period return, but then partitioning it into pieces of time, like for every year, for every whatever period you want. So that's what we're going to do here, and then minus 1. And arithmetic average is just adding them up and dividing by how many there are. So those are the 3 formulas. I'm going to copy them over. I'm going to copy all this over, and I want you to try and do it yourself. Calculate these. It's just small, but a reminder. You have to be careful when you enter to your calculator about that negative. Just be careful when you make that. You can use, there's only 4 time periods. Use the storage keys if that's easier for you, so you don't make a mess. And then we're going to talk about them, and then we're going to go, and then you guys are going to be inspired to finish at least this unit. Not this unit, but this part of the unit. Are you guys computing? Or you want to try that later? You want to at least do the first one. Just do the first one, and then I'll leave you time to work on the next one. So you're going to type 1.0549 and put it in storage 1, and then 1 minus 37, 0.37 equals, put it in storage 2. So just put them in the storage keys and then multiply them and subtract 1. That's probably the easiest. And the overall question is, did people lose during this period? Did the market recover over this period? Okay, yeah, you're using that calc and minus. Oh, because you got to make them decimal. This too confusing. You got to make them decimal.
0.01.
Exactly. You got to make it 1.0549. 0.0549, or put a percentage after it. Maybe the calculator would know that because they're all percentages. These are all percentages, guys. Yeah. If you do it like that, I don't think you can fix it because it's, yeah. So I'm going to, all right. This is what I get. You guys can practice doing that, right? So you have to use the decimals, right? Don't forget this is also negative -1, and you get negative 0.3%. It means that over that period, an investor who stayed for every dollar invested, they lost 3.3%. So they didn't do that bad, but they didn't make any money. They lost 3.3%. But it did recover substantially from the drop of 37%. Over each year, it was like a negative 1% return. So they lost each year about 1% if you want to say over average. But you see how the average, it distorts what you really see in the data, right? The data, go back. They're up here. Like it's quite dramatic, but you lose all that when you do an average, but it's still information. It still provides us information. And then the arithmetic average is actually 2.5%. So think about it. What do you think about that? Which statistics are useful? So I spent some time in my statistics review talking about when to use which statistics. You can't just, I had a student, it's very sad to say, in the PhD program one time came with printout of statistics this big. And I looked at it and I said, what are you doing? You can't just put numbers in the computer and get statistics. All variables are different. Some variables shouldn't be interpreted with certain statistics. And I had to, this is why I do a statistics review with every class that I teach, because students either didn't learn or they need to be reminded. You can't just make statistics because there's different statistics, for instance, to say the same thing. This is an average, but they're very different. Which one should I use? Which one tells the story? This is like per year. Well, overall, people lost 3.3%. So it turns out I would say this is better. When there's a difference between the geometric average return and the average return, go with the geometric average. Why? Well, and for rates in particular, it uses the compounding. Like we understand compounding interest as more meaningful. So that's what it's doing. It's compounding return. But it's the fact that the mean, the average, the way it's calculated, it's distorted by extreme values. And overall, it looks like, 2.5% a year. So if somebody didn't see all the data and they just saw the mean, they would think that they made 2.5% for every dollar invested each of the 4 years. It's not the case. I'm glad you guys are trying to make these calculations. Just be careful, like I said, with the negative, that screws you up there. Yeah, for every dollar invested from beginning to end, they lost 3.3% over that period of time. So this shows that's an average of 0.84% loss every year. That means more, right? that means that makes sense. It's like about 0.84%. It's like a 1%. This is like 3 over 4 years, and this is almost 1 for 4 years. It's about the same. But here, this average of just taking the numbers and dividing by 4 is not a very good reflection of the data. Yeah, I'll tell you in a second. So here's the story. So for in general, historically, if we look at a lot of data, which I end up doing in these notes, those returns to the S&P 500 to market performance, the return to market, so it exhibits, if you were to make a histogram, and this is what I talk about in the statistics review, and you're to smooth out the histogram, it will look relatively normal. It will be symmetric. The data will be symmetric. And this is what I get into the discussion here. So watch these videos, but essentially, here are the data. This is for US common stock over this period. I also do it for a shorter period because I had some data from a textbook. In general, the pattern is pretty much the same. Overall, the stock market, represented by the S&P 500, people invested in top performing stocks, and these will vary over the years, should expect a return of 11.4% on average. Now, this is an arithmetic mean. I can use that in this case because the data look relatively symmetric. Yeah, there's some stuff missing here, but we would smooth that out and say that's symmetric. So that's how we can use the mean calculation, and we will also use the standard deviation calculation. But for this period of volatility and very strange values, that 4-year period that we just looked at, you probably shouldn't use the mean and the standard deviation, okay? Because you can see that the mean is not a good thing. But yeah, so on average, if you put your money in the stock market over this period, or your grandparents did, they could have gotten 11.4% a year on average. But there are some years, there's, the depression and then all the recessions we've had ever since. Any individual year will be quite low, but on average, it is, over a long period of time, it's very regular and very predictable. So I want you to go back and watch. I know maybe you can watch it on fast forward, but see the statistics video to understand these shapes and to understand statistics. It's really important as a foundation for what we're doing here. In terms of the test, I'm going to look at it and I'm going to cut off that you don't have to do all of Unit 5. I'll tell you where to stop. Okay, I'm going to look at let me see here. Because I think right now in the back of my head as I'm teaching, I'm thinking maybe we can go up to you should watch the videos up to, I want to include, well, okay, up to here then. Up to review 2 solutions. Let's see what this is. Yeah, you should be able to do all of this for the test. But that means the rest is going to be on the final. Is that a better for you? Yeah, so that means you have to watch all the stuff related to all of this up to review 2. Then when we come back, I'm going to finish this and very quickly. So you should work ahead even before we see each other. You should try and finish this, but for the test, you should try and finish all of this for next Friday. But for the test, I will only test you up to review 2. All right? And I will, pardon? Yeah, you should be able to do review 1, but you got to finish watching these videos and the other videos for this CAPM stuff. Let me see the CAPM. It's a lot, but the sooner you get started, the better. Yeah. Yeah, no WAC. So you know what WAC is? You learned it before? You learned it before? You didn't learn it in 3106? You think you did? Okay. So that's what this is. This whole course is like a review of 3106, but más profundo, right? It's a much deeper treatment. So all this, that's why I'm counting on you guys, that it's a review, that it's not like a whole learning thing. So I set up to review 2 solutions, but I encourage you to, if you finish up to there, continue studying, because when we come back from the test, I will just jump right into this cost of equity. You should have that for the next week. So I will change on the platform how I have it. I have this date, April 27. No, I'm going to leave it. You should have finished all this by April 27, but for the test, I'm just going to test you up to here with the CAPM, okay? I'm just wondering if there's exercises here. This probably could be useful, this other one here. I'm going to move this up and make this, no, I think you have to watch. I think you have to watch all of it, maybe. Let me see what this is. It's just like this, there's this other set of notes. That's all I'm saying. You don't have to do this other set of notes. So where you see this other set of notes starting, you can stop there. This cost of equity, you can stop. Yeah. Is that better? No, the final is everything. The final is everything, but it's more focused on the last stuff. Yeah. So you're going to study up to, let me see which video I get up to. Probably here. Let me see here. Hold on. And I did mention to you to watch these in Brave so you don't get the ads. Okay, so this one still, I'm talking about. I guess it's all of it, because I can see already that this is. No, I guess not, because look, this is cost of equity already, so not that one. Let me see here. It must end in here. Hold on. In this one, in the second last video, I stop. I feel like there's something missing. Yeah, it's not here. Oh, I solved some questions here. Yeah, it's like halfway through the second last one. Maybe I'll mark it for you. I'll tell you till this point or something. I'll add it into the video. That's up to you. If you feel like you enjoyed this discussion and you just want to go back and review, you should be able to review quickly. Those, yeah. Those are like, I'm not going to ask you to make a histogram, or I'm not going to ask you, but you need to know the normal distribution. So go back, watch them on fast speed and get through it. So yeah, somewhere in this one, I finish. So here, cost of equity. What does that say? 1 hour? 1 hour, 1 hour, like 1 hour into this video, and that's it.